By 2050, the global population will cross 10 billion people. To feed everyone, we need to produce 60% more food than we do today. Take a look at this chart comparing population growth to available resources. While the human population climbs sharply, the global supply of arable land and fresh water is flatlining. We are running out of physical space and water to grow crops. In the past, we solved production deficits with raw physical power and mechanization, like the hand-cranked gears of the cotton gin seen here. But adding more horsepower and heavy machinery to a finite amount of land has reached the absolute limits of physics. We can no longer solve the food deficit by clearing more acreage or planting more seeds. To survive, we have to plant smarter. Preventing a global food collapse depends on plugging the physical farm into the Internet of Things. This digital integration is the technical core of Agriculture 4.0. Solving the space crisis requires decoupling food production from the traditional requirement of flat rural land. Inside city limits, urban vertical farms act as localized plant factories. They use stacked rows, precise LED lighting, and tightly controlled microclimates to grow crops right where people actually live. Agricultural engineering is conquering extreme environments. By combining solar power with water desalination, they cultivate high-yield crops in the middle of arid deserts. Offshore, ocean-based algae farming is emerging as an alternative crop. Algae requires zero fresh water or soil to grow, yet it provides highly nutritious animal feed and can even be converted into biofuel. By redefining where and what we farm, we drastically lower the spatial and environmental footprint required to maintain the human food base. We are also changing how we manage that food, moving away from human intuition toward automated, real-time adaptation. Instead of a farmer walking the rows to visually inspect crops, aerial drones now scan fields using specialized multispectral light sensors. These sensors detect microscopic plant stress, like dehydration or early-stage disease, long before a human eye could see it. This sensor data feeds a digital twin, a live simulation mapping color-coded nodes over crops. It instantly dispatches a cobot along a precise vector to any stressed plant. Instead of blanket spraying, cobots apply microdoses to the distressed plant, updating the field's health metrics. This closed-loop digital management system turns farming from a reactive game of chance into a highly predictive, zero-waste science. Once a crop is grown and harvested, it enters the final phase of the agricultural life cycle, secure distribution to the global consumer. Traditional, elongated supply chains are full of systemic blind spots. When commodities change hands through multiple opaque intermediaries, it inevitably leads to untraceable contamination outbreaks and widespread food fraud. To fix this, the industry is adopting blockchain. As shown in this network map, blockchain creates an immutable, decentralized digital ledger where every physical movement of a crop locks a permanent, time-stamped block of data into an unbreakable chain. This cryptographic ledger places verification directly in the hands of everyday consumers. With a simple smartphone scan, anyone can confirm the geographic origin, the full transit path, and its ethical footprint, all before they even buy it. By injecting transparent data into the supply chain, we eliminate those systemic blind spots and rebuild essential trust between the person who grows the food and the person eating it. When we zoom out, we see three shifts: innovative growing environments, autonomous robotics, and cryptographic ledgers operating together as a single ecosystem. A localized drop in soil moisture triggers an overhead drone, which guides a ground-based cobot to water the plant, which simultaneously updates the distribution ledger, all in a fraction of a second, without a single moment of human hesitation. This intense level of automation does not erase the human farmer, it elevates them. They transition from performing manual, physical labor to acting as the strategic managers of a highly complex ecosystem. Securing the future of humanity depends on the technology rooted in our soil. The vital breakthroughs of the next century are happening in the dirt.